Okay, today we're going to be talking about section 3.3, which is expanding and condensing logarithmic expressions. And basically the biggest thing that I need your brain to remember is the change of base formula. Way back in the day, the change of base formula was given, and the reason why it was given is because we were not able to calculate the base of just any logarithm. We could only calculate a base of e and a base of 10. If it was a base of 2, we had to use the change of base formula to create it and make it go into a base of 10 or a base of e. Okay? So pretty much what we're going to be doing today is log base a, where a is any base you want it to be, or any base is given, is of x is equal to log base b of the base you are choosing of x over log base b of a. Or log base a of x is natural log of x over natural log of a. Super easy for you to think of it that way. So an example. I give you log base 10, don't know what my brain is doing here. Had a paper slide on my desk, so I'm a little bit like, what's going on? Log base 4 of, let's say, x over 10. Okay, x over 10 is just going to be your x. Okay, it's okay for it to be ugly like that. So this is going to be the natural log of x over 10 over the natural log of 4. That's how you would calculate it. If I were to have the natural log of 5 of y, then that's going to be the natural log of y over the natural log of 5. Okay? If I want to use the other base of 10, log base 2 of, let's say, 15, that's going to be log base 10 of 15 over log base 10 of 2. Now, here's what I need your brain to understand. This 10 does not have to be written, meaning I can have it be log of 15 over log of 2, and it is understood to have a base of 10. So anytime you do not see a base with the words log, it automatically has a base of 10. Okay? That is the change of base formula. Now, an example, log base 4 of 25. If you said the natural log of 25 over the natural log of 4, or if you said log of 25 over log of 4, you would be right. When I plug this into my calculator, and I put log base 4 of 25, this is the decimal I get. If I go ahead and I put natural log of 25 divided by the natural log of 4, do you see it's exactly the same decimal? If I do log of 25, but I have to put the 10 there, sorry. My calculator requires the base there, of 25 divided by log base 10 of 4, they're all exactly the same decimal. Okay, super important that your brain understands that. Okay, so that was 2.319, I think. I'm going to go with it. Okay. Next, same thing with this. Natural log of 7 over the natural log of 3. And you're going to come over to your calculator and you're going to plug that in. Natural log of 7 divided by the natural log of 3, and hit enter, and it's 1.77. Okay? Then we have properties of logarithm. Properties of logarithms, these are the things that allow us to expand, making larger, and condense, making smaller. Okay? So, if I am condensed at log base a of 3 times v, or u times v, I can expand that to become log base a of u plus log base a of v. And I can write it as two separate logarithms then. Same thing here. This is the condensed side. This is the expanded side. Condensed side, expanded side. Grabbed the wrong one there, guys. Okay? Now, in log world, if your bases are attached by multiplication, that means addition. If they're attached by division, that means subtraction. If it is a power, then that means it's multiplication out in front. What do I mean? And FYI, super important, Very, very important that you understand the natural log has exactly the same properties. So here we go. Let's expand, okay? So you need to see how all of these are attached. Every one of these are attached by multiplication. So multiplication in log world means addition. So this is going to be log base 4 of 5 plus log base 4 of x cubed plus log base 4 of y. Okay? So now I had 3 logarithm bases attached by multiplication. I wrote them as 3 separate logarithms. So now we're going to go ahead and see if we have any powers. There are no powers on the first logarithm, so I drop it down. Are there any powers on the second one? Yes, there are. That 3 is going to go out in front to make that 3 times log base 4 of x plus log base 4 of y. This is the expanded form of the given logarithm log base 4 of 5x cubed y. So let's do this again. Same exact concept. We're still expanding, okay? So what your brain should see is that you should see a numerator, you should see a divider, and then you should see the denominator. So those are kind of 3 things that I need your brain to see. So with that being said, the very first thing I see is division, which means in log world, subtraction. Okay? Then I look at this and I say, hey, that is a very weird thing. It's the square root symbol. Well, the square root symbol can be replaced by using power over root, which means this is the natural log of 3x minus 5 to the first over 2 root. Power's 1, root is 2, minus the natural log of 7. Now I can take this 1/2 and put it out in front by multiplication, keeping parentheses around the base of 3x minus 5. And then this is the complete expanded form. That is expanding. Okay? So we've taught expanding, so now we're going to do the opposite, which is going to be condensing. Condensing means I'm giving you a whole bunch of logarithms, and I want you to write it as one logarithm as much as you possibly can. In order for that to happen, your log bases must be exactly the same. So I'm going to look at my log bases, and they're log, and there's no base there. Remember I said if there's not a base, then the base is actually 10. So that means I am going to go ahead and do my first thing that I did, my last thing that I am going to do what I need to do first, sorry. The last thing I did when I expanded is the first thing I do when I condense. The last thing that I did when I expanded was I got rid of the powers. So this means when I condense, I'm going to put the powers back on my bases. So this is going to give me log base 10 of x to the 1/2 plus log base 10 of x plus 1 to the 3rd power. Notice how I'm saying log base 10? I don't have to, though. That is something your brain needs to understand. I'm saying it so that you understand it is there. Now, in log world, addition is multiplication. So that means I'm going to go ahead, before I put these as multiplication, I'm going to deal with this ugly little fractional exponent. That fractional exponent is actually the square root of x. And then I'm going to say, okay, well, in log world, that means addition is actually multiplication. And then I am done. I have one logarithm and everything is attached together. Okay, so let's go ahead and do this one more time. This time you'll see that you have brackets. Brackets are exactly the same as what they've always been. You take care of what's inside the brackets first before you do anything else. So I'm going to condense the bracket. The very first thing I'm going to notice is that I have a base of 2, and I have 2 logarithms that both have a base of 2, and those 2 logarithms are attached by addition. And there are no powers on the outside except for the 1/3 outside of the bracket that I will do last. Log base 2 of x times x minus 4. Okay? Now, this 1/3 is going to go to both of these, so that means I'm going to have log base 2 of x times x minus 4 to the 1/3 power. Now, if I wanted to, I could distribute this. Log base 2 of x squared minus 4x to the 1/3 power. That 1/3 power is the same thing as the cube root of x squared minus 4x. And that is done then. Okay? Tonight's homework is going to be 3-3, worksheet 1, expand and condense logarithms. So we're going to go straight into tonight's homework. I was going to make 2 different videos, but we're going to go right into it. Okay? So, tonight's homework, directions say, use the change of base formula to evaluate each of the following. So, I'm going to say, okay, well, this has a base of 15, so I'm going to use the natural log of 1,460 divided by the natural log of 15. If you wanted to use log base 10 of 1460 over log base 10 of 15, you would still get exactly the same thing. So let's go ahead and put that in there. And I'm going to do the natural log of 1460 divided by the natural log of 15. And that is going to give me not the right thing because I forgot the 5. I forgot the 1. 15. That's going to give you 2.69. 2.69, and that is done. That is how you're going to do problems 1 and 2. Problem 3, it says use the properties of the logarithms to rewrite and simplify the logarithmic expression. Okay, listen up. Your goal is to take the left-hand side and make it look like the right-hand side. You do not touch the right-hand side. You are going to focus completely on the left-hand side. Okay, so that means I have log base 5. This is division of 1 minus log base 5 of 250. Okay? Now, what is something you could do here? Log base 5 of 1 minus, this is going to be log base 5 of 125 times 2. Okay? This is log base 5 of 1 minus log base 5 of 5 cubed times 2. Keep going. Log base 5 of 1 exponentially says 5 raised to what power is 1? If you answer that this is going to be a 0, you are right. That turns out to be 0. So now we have minus log base 5 of 5 cubed minus 2. So if I separate these, this is going to be negative log base 5 of 5 cubed plus log base 5 of 2. And notice I put brackets there. Put the 3 out in front. Plus log base 5 of 2. That cancels out. Negative 3 plus log base 5 of 2. Go ahead and distribute this. Negative 3 minus log base 5 of 2. I proved that the left-hand side is equal to the right-hand side. Now, I did one way. There's multiple ways you could do this. There's actually probably a shorter way, but this is one way that your brain could have done it. Okay? Number 7. Number 7 said expand each of the following logarithms. So how do I expand this? Well, I see many bases here. So I'm going to do this one right here, which is the division. So this is the natural log of x to the 4th times the 5th root of y cubed minus the natural log of z to the 5th. Okay? Next, I'm going to go ahead and separate this, the natural log of x to the 4th plus the natural log of the 5th root of y cubed minus the natural log of z to the 5th. Now, my eye does not like this. So rewrite it. Natural log of x to the 4th plus the natural log power over root. It gives you the 3/5. Next, we're going to go ahead and bring all of our powers out front by multiplication. 4 times the natural log of x plus 3/5 times the natural log of y minus 5 times the natural log of z. This is the expanded form of number 7. Okay, number 11. Same exact process, I see a division. So this is the natural log of x minus the natural log of the square root of x squared plus 1. My eye is drawn to this. I do not like it, so I'm going to do power over root to that. So that's x squared plus 1 raised to the 1/2 power. Natural log of x minus 1/2 times the natural log of x squared plus 1. You have to keep the parentheses there. Why? Because these two items are attached by addition and it's necessary to stay. Okay, turn your paper over. Number 17, the directions say to condense each of the expressions into a single logarithm. So we work from brackets inside out. So the very first thing we need to do is put on missing powers back on. So I have the 1/3 natural log of y plus, put this 2 back on, the natural log of y plus 4 squared, natural log of y minus 1. Inside here, I'm attached by addition. That means I'm going to go ahead and have a third bracket, natural log of y times y plus 4 squared, minus the natural log of y minus 1. Now I have to deal with this bracket, meaning this bracket needs to have that 1/3 put back on it. So I'm going to go ahead and make this the natural log of y times y plus 4 squared to the 1/3 power. That 1/3 power is simply going to be rewritten as the natural log of the cube root of y times y plus 4 squared minus the natural log of y minus 1. In log world, subtraction is the same thing as division. This stays up in the numerator, and it's all over the denominator. And that is done now. Okay? Let's go ahead and do number 21. Number 21 is very similar to the last problem. Look inside the brackets and go ahead and work from the inside out. In log world, addition is multiplication. Go ahead and put this 2 back on. Go ahead and put this 4 on. So that's going to be y to the 4th times y plus 5 to the 4th. Minus the natural log of y minus 5 squared. Notice how I put it to both of them? Instead of putting parentheses, you can do that as well. In log world, subtraction is division. So this is y to the 4th times y plus 5 to the 4th, all over y minus 5 squared. And that is done. And the last set of instructions say find the exact value of the logarithm without a calculator if possible. Now we did these previously, so we're going to keep on going with them. Oh, sorry. So I have log base 6 of 6 to the 1/3 power. Power is 1, my root is 3. Those cancel out and I'm left with just 1/3. Done. Okay? Over here, have the natural log of 1 over e to the 1/2. It is in the denominator, so to move it to the numerator, that becomes a negative 1/2. This is log base e of e to the negative 1/2. Those cancel out to give you negative 1/2. Okay? That is section 3.3. If you have any questions, please let me know.